Today, they are getting closer to finding out why Challenger disintegrated halfway to the heavens. Less than 2 months since the shuttle disaster took place, investigators have ruled out every possible reason for the explosion save one: a bad joint on the right solid rocket booster. As ABC's Lynn Scher reports, the case is being made to the Presidential Commission with the help of some revealing new pictures, a visual countdown of disaster in the making.
It is the first new film of the Challenger accident, the output of 14 cameras, including this angle of the explosion itself taken by a private citizen from a spot north of the launch pad. And it shows more clearly the solid rocket boosters being blown up by remote control. NASA used computer enhancement to isolate key moments in the final seconds of the deadly chain of events. The first sign of flame escaping from the rocket, the flash of fire between Challenger and the giant fuel tank, and from two different angles, the flash that caused the ultimate catastrophe. And this new perspective on the dark puff of smoke that appeared at rocket ignition. Watching the pictures again was clearly difficult for commission members, and one NASA engineer in the audience averted his eyes when Challenger blew up. Then NASA indicated for the first time that they've settled on the joint of the right-hand rocket's lower segment as the mechanism that failed. That's where they believe the dark puff of smoke originated.
We feel that it does come from the joint. Yes, sir.
The scenario they now favor works this way. The first line of defense against hot gas escaping, the putty protecting the rubber O-rings, became brittle in the cold and let tiny holes form. That in turn focused super hot jets of gas on the O-rings, which lost their resiliency in the cold. The combination coming at rocket ignition when internal pressure caused the joint to flex prevented the O-rings from seating properly in their grooves. That allowed gas from the solid propellant to shoot past them and lick right through the joint. As the load eased just after liftoff, one O-ring may have sealed temporarily. But then came the cumulative effects of the shuttle's routine struggle to leave Earth's gravity, the immense thrust of its rockets and engines fighting resistance from surrounding winds. The joint failed entirely.
This chart shows the shuttle going on a fairly bumpy road prior to that time with loads on that SRB. If you had a weakened joint that had sealed itself on liftoff, this could be the factor that opened that joint up again. Is that right?
We're very much interested in that theory.
Good.
The commission also learned about the recovery of this chunk of what's believed to be the right rocket. Although not from the location of the probable leak, it formed part of the casing on the other side of the rocket. Identifying it means the critical section could be lying nearby on the ocean floor. But sources close to the commission say even if they don't find the hardware now that they've decided the joint is the culprit, it will be redesigned. And along with indications that NASA may recommend a wide range of design changes, their stated target of flying again in 1987 may be optimistic at best. Lynn Scher, ABC News, Washington.